Assalamualaikum and greetings to everyone. My name is Nurhanum binti Omar from Polytechnic Ibrahim Sultan. First and foremost, I want to thank the organizer for giving me the opportunity to present my topic, a design and development of an autonomous tennis ball collector using Raspberry Pi. For introduction, tennis is a popular sport that has gained popularity in recent years. Similarly, the number of coaching or training sessions has increased, with most tennis trainees concerned about the difficult task of manually collecting tennis ball after each training session. As tennis courts frequently become cluttered with balls when in use. A, a number of robotic tennis ball retrievers have been developed over the years, but they have numerous drawbacks. Time waste, insufficient rest time, and increased energy exhaustion are all major contributors to poor training session performance. Because of a lack of technological breakthrough, the topic of obstacle in sport has become contentious. The difficulty of picking up tennis ball by hand was highlighted by players who expressed strong interest in a device that could do so for them. Manually collecting balls with a hand-operated collection tool takes about 5 minutes, and balls must be recollected every 20 to 25 minutes. The most common complaint from players who collect balls by hand is the strain on their backs or wrists caused by bending down and gathering many balls onto a tennis racket. Most players would prefer an autonomous device to quickly collect the tennis ball rather than exerting energy to manually pick up the tennis ball. So, the objective of this study is to design and develop an autonomous tennis ball collector that can gather balls from one side of the court automatically. Okay, for the literature review, there are 5 examples of the previous work. First, the development of an autonomous tennis ball retriever robot from Duru Sarikala proposed the design and implementation of an autonomous robot that collects tennis ball autonomously. In this development, a camera is placed 2 meters above the ground surface to obtain the required image from localization and planning. MATLAB software is used to control the vehicle after image processing. Second, design and control of a tennis ball collector robot from Wahbi Umur Chabuk presented that the robot perceives the balls with a camera mounted on it and begins collecting the balls from the closest one. The system employs a rotary shaft mechanism that eliminates the need for an additional actuator for ball collection. However, when the balls are taken into storage, they may squeeze in the system. Third, interactive smart tennis ball collecting vehicle from Hung Kwang Chen proposed a patented smart tennis ball collecting vehicle in Taiwan. A smart vehicle with interactive and automatic program navigation control, on the other hand, is built on top of an Arduino microcontroller and an Android-based smartphone to reduce labor and human intervention. The novel design is more efficient and user-friendly than traditional approach. For the 4th literature review, Ilham Vazuti proposed the development of an autonomous tennis ball retriever robot for the sports industry. By sweeping around the tennis court, the developed autonomous robot can retrieve tennis ball. The paper goes over the system configuration in terms of mechanical and controller subsystem, navigation, and overall system performance. In 2016, Hatem El-Trabi presented TennyBot, intelligent tennis ball collecting robot with multiple sensor and local camera. When the robot detects a ball, it moves toward it and picks it up. Then the robot moves on to the next ball until all balls have been collected. The robot can move autonomously around the tennis court using two flywheels to collect balls and deposit them in a bucket thanks to computer vision. Okay. Okay, for methodology, this system can divide into two parts, mechanical subsystem and electronic subsystem. So for mechanical subsystem, the frame is made up of 18 aluminium T-slot of varying size of structural framing with additional support across the base and rotating cylinder placement. This was a deliberate design choice because it is quite versatile and will simplify assembly. T-slot have the advantage of allowing other parts to be easily connected to the frame. Furthermore, the T-slot are extremely strong and lightweight, supporting the weight of the tennis ball with ease. Okay. Rubber wheels are used for connected to motor that drive the robot. Besides that, DC motor are attached to the T-slot via motor mounts that are screwed in place. These motors are linked to motor controller which are controlled by Arduino Nano. In this slide, this is an isometric view of CAD model and the below one is side view of robot for battery, support panel and vertical slot. The tennis ball moves up a ramp made of acrylic panels with walls to keep the tennis from flying off. The storage compartment at an angle provided additional support for the tennis ball while also removing some of the weight from the robot's motor shaft. The functionality is demonstrated by viewing the court with image detection software and identifying the tennis ball present. The robot will then adjust its position and move to the nearest available tennis ball location. As the robot moves, two long arms will be sticking out from the sides, corralling the balls toward the center of the robot. The tennis ball was pulled into the rotating cylinder and shot up a ramp into a storage compartment due to the movement of the tennis ball and the power of rotating cylinder. The electronic circuit is split into two parts, camera vision and image processing and motor control. A Raspberry Pi 4 Model B, a USB camera, an ultrasonic sensor, and a 12-volt power source connected to a 12-volt to 5-volt step-down module comprise the camera vision compartment. Okay. The Raspberry Pi is linked to a USB camera and an ultrasonic sensor to enable camera vision component, which are needed to detect obstacle and tennis ball. Besides that, this project also uses Arduino Nano. Arduino Nano is programmed to interact with the Raspberry Pi to get commands to control motor driver, which will eventually control the speed and direction of DC motor. Okay. This figure shows the electronic circuit designed for electronic subsystem. Okay. The motor controller requires 6 input logic pins to be connected to the Arduino Nano, while the BTS7960 motor controller requires 4 pins. This means that the motor controllers will occupy 14 of the Arduino Nano's 22 pins. Okay. This is the general operation of the system that provided in a flow chart. This slide shows the final assembled autonomous tennis ball collector. The tennis ball collector has a tough and stable design. The control subsystem includes an HCSR04 ultrasonic sensor, a Raspberry Pi 4 Model B microcontroller board, a USB camera, a DC motor driver, a power supply, and DC to DC converter. Okay. So for analysis and finding, okay, the Phyton Programming Language was used to create a Raspberry Pi programming code. The programming code can be divided into segments. The ball collector.py segment is used to collect tennis ball. There is a threshold parameter that is set to collect the tennis ball in an expected manner. Then the ball detector.py segment is used to detect tennis balls scattered around the court. This segment is programmed to detect a tennis ball and draw a virtual circle around it before converting it to integers. This programming could also include the Kenny processor.py segment, which is used to pre-process video footage before applying the Kenny edge detection process. This pre-processor process acts as a filter before the Kenny edge detection process detects edge. In addition, imageSource.py is used to define the video source that will be used for tennis ball detection. Furthermore, the threshold processor.py segment function is used to define the upper and lower threshold that will be used to find tennis ball. It also converts the video source to grayscale to facilitate the Kenny detection process. Furthermore, the detection utility.py segment functions to resize the aspect ratio using a formula with integers such as height and width to achieve a constant aspect ratio every time. Not to be overlooked, the range detector.py segment is used to detect the range from the track fencing as well as to set up argument with all the properties. Among all of the above segments, the main.py segment is used for importing all of the different programming used into a single programming file so that it can be executed with a single file only. At the same time, this programming code sets the video source as well as the parameter for the tennis ball yellow color. Okay. The ability of this tennis ball collector to collect tennis ball has been tested. Okay. The purpose of this test is to see how effectively the robot gathers, transport and store the tennis ball. This test determines how effective the ball collection subsystem is while the robot is moving. It entails moving the robot around a tennis court full of balls and counting the number of balls successfully shot through the spinning cylinder, up the ramp and into the storage compartment. However, due to time constraint, this test was only performed 5 times with 10 tennis balls. The data in Table 1 show the effectiveness of ball collection. In the first trial, 6 out of 10 balls are collected properly. It was able to collect 7 out of 10 balls in the second and fourth trial. As a result, the mechanism demonstrated an average of 80% collecting effectiveness during the trials. Throughout the demonstration, the robot was able to collect the majority of the ball. For the 5-time trial, the average time to finish collecting 10 tennis balls is 9 minutes 23 seconds. As a conclusion, this study demonstrates the development and testing of an autonomous tennis ball collector. Although the performance of the tennis ball collector was satisfactory, it could be improved further. A more in-depth analysis of the approach in terms of ball collection speed, mechanism cost, and efficiency could be included in future work. Future research could improve the mechanism by incorporating a more accurate path tracking algorithm and more functional image processing method. Furthermore, the storage compartment size could be increased to accommodate more balls at once. That's all for my presentation. Thank you.